Hello everyone, it's Caller from 19. Today's 83, my challenge day. And so what I'm going to do is, let me see. So finally, I'm going to start writing some ray tracing algorithm calls in the computer shader pipeline. So before I start, I will show you just a small result that I make after previous video. Source application. So if I run this with the render doc application, so we can see that this ray trace image. So this is actually uh, not the image rendered by the rasterization pipeline. Is a ray traced image by a computer shader using a rayQuery function. So if you see this shader code, to make this image, we need ray origin to determine where the ray starts, and by using a transformation equation for the screen UV coordinate. And also we define the vertical slope. It determines that whether about how much the shape in the scene will be extended vertically. And finally, we can get this ray direction by this screen UV coordinate. So with those parameters, if we call the rayQuery initialize extension function, we can initialize the rayQuery object. And finally, we can um, before we trace the ray, we can update the committed intersection, which is the closest hit about the current ray with the mesh, and then we can call the rayQuery get intersection extension function. By calling this function, we can get a t coefficient of the ray, which it means determines the distance of the ray, and just t means that t is just kind of a range. And if we divide it with a 10, we can get the value between the range by normalize it. And surely we can get this grayscale image. Okay, then let's start to write some intersection code for So to build a path tracer, we need to compute how light interacts with each other meshes, and that means we need additional information other than the t values of the ray. So in this case, we can think of that the number of intersections, the current ray along the lines of the ray. So if we want it, we need to change this flag as a no opaque extension. Because if we set the ray flags opaque extension flag here, this ray query proceed extension just returned right away because it doesn't need to find additional intersection along the line. After that, we can count the number of intersections. Start from zero. Let's use float. Intersections. So the brighter part represent the number of intersections is higher than other parts. So with this dark part, there is no intersection at all about this. But if you see these, just these, the war parts have just one intersections. So in this case, it's darker than these boxes. But if you see this, because we don't set this no opaque flags, ray pass through this area, pass through these pixels, can intersected with the first box and the second box and the wall. So there's a three intersections along the line. So that's why this is the brightest part in this scene. No duplicate any location. Rewrite this from happening one ways to add. So my rendered image is slightly different the image in the tutorial, but I think there may be some updates after the tutorial made. So I think some of the contributors fixed this problem, like any shaders. Some color GPU runs for any intersection on the array, for instance. Right. to line calculations. The overall structure for most ray queries will usually be similar, initialize, proceed, loop, for generation. So this example shows us that uh, it is possible that for us to write some other intersection code in the rayQueryProceed extension while loop, so that we can trigger some of other different intersections events for the each intersections. So that means it is our choice to write some additional code in this loop. Also, we can uh, write some intersection events for the AABB instances, which is a non-triangle mesh. This is an abbreviation word of the axis aligned bounding volume, a bounding box. Where you get intersection type extension, generate intersection extension. Okay. Reader might have the area through every scene section of the scenes. So it was just for the test. Let's make the revert the changes back to our original shader. We didn't have these initially. We want t value. What are the things? Ray Ray Curry got intersection type extension to determine what kind of ray intersect. If the ray missed the scene entirely, this function takes a ray query in whether to return the committed or candidate intersection. Since we won't use the interior of the rayQuery proceed loop from here on, this will always be true. And returns a UE that tells us if there's nothing, a triangle or generated procedural. So there is a ray curry intersection type extension function. So this function to determine what kind of object the current ray intersected with, or whether the ray missed uh, ray the missed the scene entirely or not. And also this function returns the u unsigned integer to our application so that we can determine that whether it is array mesh or whether is a triangle or is just procedural meshes defined by us. And with those information, we can determine a different intersection events on the meshes. So for example, if it's the ray miss, if the ray misses the scene entirely, at this case, we can just return a default value. Or if the ray intersection with the procedural meshes or the triangle meshes, at this case, we can determine some of the specular reflection or the diffuse reflection and so on. So for the tacit, we can just write some simple code for after the ray query intersection, the extern check if the ray hits something. Ray query intersection type extern type ray true. And if this is the same with the ray query commutative intersection triangle extension, so in this case we want to get the pixel color as, let's create the pixel color. We want pixel color as x3 0.0, 1.0, 0.0. And otherwise, want the pixel color as blue. 3, 0.0, 0.0, and 1.0. Let's delete this function. And then let's assign the pixel color here. If we test it, not x, else. We succeeded. If you see the render dog, as you can see, this corner box area intersected this whole scene with intersected with our rays so that it has a green value as we assign it. And if you see the background, which is there's no model at all, so all of the rays shooting this pixel region is missed, so that it has some blue color as we expected. So this is basically how we can use the what's mean? Ray query get intersection type extension function. We can get information about the triangle, the ray heat. First, to get information about the triangle of the ray heat using ray query get intersection primitive index extension. Takes a ray query, accommodate for candidate plane, primitive affinity index of the triangle from 0 to first three elements of the index buffer specified triangle 0. Okay, so then we can get information about the intersected uh, heated triangle by array using the rayQuery get intersection primitive index extension function, which is a long name. But anyways, it's just simple. It takes the rayQuery object and it returns a primitive ID identifier. So this primitive identifier is equal to the index of the triangle, which is the range from 0 to the max primitive count -1. And we to avoid the duplicates on the vertices, we just define the vertices of the obj model first. So these vertices has no duplicates at all, but we just need to tolerate for the duplication on the indices because it has a lower memory. It takes a lower memory space than the vertices because vertices has a 4 byte of float and 4 by 3. Uh, so it each vertex takes 12 bytes for each, but we use 4 byte for just single indices, and the single indices can represent a vertex, so which is uh, just 30% of memory space of the vertex. So we can use the duplication on the indices. So anyways, if we call this function, it returns the triangle index. So this triangle index is composed of the 3 indices of in the index buffer. These 3 indices point to each vertex in the vertex buffer. Okay, this is the some kind of hierarchy between the primitive ID of the triangle and to the vertex. Okay, so replace the first branch if statement. So if it is intersection with the commutative uh, with the mesh, if it is not a ray miss, in this case we want to get a primitive ID. So that is primitive ID with the rayQuery get intersection instance custom index extension. Nope. rayQuery get intersection primitive ID index extension rayQuery with the true. And the pixel color will be backstreet primitive ID. So there is some error. There was a typo. So if we run it, let's see. This is so cool thing, right? So if you see keep notice on this scene, you can see some of the triangles has some same color. So let me show you these ceiling light and this fourth box has the same color. Why? Because they are the same triangle. Uh, they yeah, they have some same primitive ID. because we are tolerating the duplication on the indices. Also, if you see these, the background of this triangle and the ceiling triangle has the same color. So, okay, I'm going to use this as a thumbnail. And then base-centric coordinates. So finally, we can determine where the ray intersected the triangle. We can determine where the ray intersected with the triangle. More specifically, base-centric coordinates tell us where the intersection is relative to the base of the triangle. A triangle has three bases less number. Given an intersection at point P in the triangle, rayQuery intersection base-centric carries a magnitude such that defines Vx, Vy, Vx, and Vy are the barycentric coordinate of the intersection, and the equation will give us way to get the word space function. So if we use the barycentric coordinates here, x, so color aspect 3, 0.0, array curve intersection, barycentric. What is So this barycentric coordinate is the coordinate from of is used by the triangles, each triangle, and these rayQuery intersection barycentric extension function tells us the where the intersection is relative to the vertices of the triangle. So for example, when we have this kind of triangle with the vertex index of 0, 1, 2, if we follow this equation, the barycentric extension function give us these points so that we can determine the where the intersection is relative to vertices of the triangle. But still, we don't know the where really the where is the intersection of the triangle in the word space. Okay, before we move on to chapter 10, let's summary everything that I learned today. So let's go to random algorithms. The second is depth image. T value sign grayscale color. So algorithm will be the GLSL. Is next thing was to determine if hit or miss. So we can get this as ray curry get intersection type extension sign. Sure. See-through match. Next thing was get triangle indices. Use get intersection give x extension function was a barycentric coordinates. This is all the things that I learned to utilize some rayQuery APIs to get the base-centric coordinates or your triangle indices, which is a primitive identifier, and to determine if it is a hit or miss. And if it is hit, uh, it is whether the procedure mesh hit or the triangle mesh hit. Or so I render the depth image. So okay, thanks for your watching today's video and see you next video.